board. All right, so you wanted to see. Goodness. All right. So I'll do it on here. You wanted to see number 50, which one was it? 56?
Yeah, 56 and 59 and 60.
Okay, so let's see if I can find an empty graph here and copy it. There we go. All right, so number 56 kind of looked like this. Sorry, I'm trying to get ahead with some of the notes in the assignment. So number 56 said this. We've got x plus 6 if x is less than or equal to -4. We've got 3x minus 4. So we're going to move on from this stuff today using some of the stuff that we've already learned. 3x minus 4 if x is greater than -4. Oh, there we go. So again, all you have to do on this is I only use this equation when this happens. So if I want to go ahead and make a very quick table, sorry, you guys can see why it drives me crazy. Kegler's here, Sassman's here, Welch is here, still missing a couple. All right. So if this is what we've got, I want to start with this value. So I only use this equation if x is less than or equal to -4. So, and I need a number smaller than -4, which I'll pick like -5. So plug them in. So if x is -4, and I know again at -4, it's going to be a closed circle, right? So -4 plus 6 is 2, -5 plus 6 is 1. So at -1, 2, 3, 4, 2, closed circle, -5, 1, closed circle, and it's everything less than that. Sorry, that's a terrible line. So everything less than that, just like that. I'll do the other one in light blue. So I only use this equation when x is greater than -4. So I still have to start with -4, but I want everything greater than that, and I'll go ahead and pick like 0. I could have picked -3, that's fine. But if I plug in -4, I get -12, minus 4 is -16. If I plug in 0, I get -4. So at -4, -16, which is way down here, and it should be open. Why is it open again?
Because it doesn't have the equal sign underneath it.
Yeah, because it's exclusive. It doesn't have the or equal to. So then 0, -4, 1, 2, 3, 4 is right here. So that's it. Okay. That's number 56. I know it goes off the graph, but just somewhere down there, show me what it looks like. Again, I guarantee we only had, what, 3 or 4 questions yesterday? At least 2 of those will be on your homework check on Friday. So let's do, what was the other one you said?
59.
All right, and that'll be the last one from yesterday that I'm going to do. So 59 says this, my function, when I've got x plus 3, I've got 3, and I have 2x minus 1. So if x is less than or equal to 0, between, oh, that's just a 2, between 0 and 2, and then the last one is when x is greater than 2. So the first one with this one, I only use that if x is less than or equal to 0. So again, I have to use 0 and it's going to be closed. It's going to be closed because of the or equal to. The other value, something less than 0, so like -1, plug it in. So at 0, 3, it's going to be closed. At -1, it's 2, and I want all my values less than that, so it has to go this way. One of the things I'm checking for, remember, it is only good when x is less than or equal to 0. That's the only time I use this line. So it's not an arrow straight through. If I see that, it's going to be wrong. It has to have a hard stop at 0. The next one, it is a constant value. There's no x's, so it's going to be 3 whenever it's between 0 and 2. So again, if I want to make the table, all I have to do is, so use those two values, 0 and 2, and it's open here, and it's closed here. Well, no matter what I plug in, it's still going to be 3. So at 0, 3, it's open. Oh, but it's already accounted for. And then it's going to be 3 all the way to 1, 2. Now the next part, right here, which I will do in green. So when x is greater than 2, so I have to start with 2, and it's going to be open. And then a number bigger than 2, so let's pick 3. 4 minus 1 is 3. 3 times 2 is 6. Minus 1 is 5. So at the point 2, 3, it's open. And then at 3, 1, 2, 3, 1, 2, 3, 4, 5. That's going to go on forever. Now somebody's going to say, how do I know what's what? Well, when you graph it, what this is really going to look like when you graph it, it's just going to be this. So that information tells me which one to use and what the value is. But at 0, it's still going to be 3. At positive 2, it's still going to be 3. All right, so any questions?
Yeah, why does the arrow go up?
Why does the arrow right here, why does this go up? Because I want all of my x values greater than 2. So if I would have picked another one, so I went from 3 bigger than 2, so I could have gone 4, 5, and my x's are going to keep going all the way to infinity. So it has to keep following this all the way up and all the way over. All right, so that's why you really have to pay attention to the signs, and that is the tricky part. So I know people will come up here and they'll get the equation right, they'll graph it right, but then they'll think it goes all the way through. This equation is only good until you get to 0. So it's good from any value left of 0 or less than 0 all the way until you get to 0. Does that make sense? Any other questions?
So for where it says 3 and then it's 0, less than x, less than or greater to the 0, do we have to find like a number smaller than 3?
No, you don't. So what this means, again, what this means is my value is always going to be 3. That's a constant. There's no variable here, right? It's always going to be 3 as long as my x's are in between these two values. So as long as my x's are in between here and here, my value is going to stay 3.
Oh, okay, cool.
Okay, good questions. And before we move on from this, because we'll come back to it actually today here in just a minute, we're going to wrap all of this stuff up with interval notation and doing some of this, so it should make sense. And that's why I really wanted to start it with this anyway. So what other questions do you guys have? I don't want to spend too much time.
Can you do 45?
On that, is that on the same page? No. 45 was on page 25. Yeah. So number 45 says this. But it only wanted you to evaluate it for these values. So 45 said this. And this will be the last one we do, then we've got to move on. So this says, what's the value of my function when x is -2? Which variable do I use? Which equation do I use if x is -2? The top one, the middle one, or the bottom one?
Top one.
The top one. So this is saying when x is -2, well, I use the top one for any values where x is less than 0. So because x is -2, which is less than 0, I plug it in here, which is -2 plus 2, and my answer is 0. Which equation do I use if my x value is 0?
The second one?
Yeah, because it's x is between, including 0, between 0 and 2, including 0, so there's no x there, so it's just 4.
So does it have to have a less than or equal to sign if you're gonna keep the same number?
So less than or equal, I'm not exactly sure what you mean. So for
Wow.
instance, let me just change this up real quick and see how this works. If I change this up, and this is what it looked like. Now, all of a sudden, I would use this equation for it because I want to know what's the value of my function when x is 0, right? So I use the top one because that's less than or equal to 0. So what's the value here? Well, if I plugged in 0, 0 plus 2 would equal 2, and now my answer would be 2. So this is telling you what your x value is. This right here is telling you when do I use it? Which equation do I use for these values? Let me get rid of some of that stuff. Change it back. There we go. So if your x value is 2, because I see that it's greater than or equal to 2, so it's equal to 2, I plug it in right here. Remember, 2 squared is 4, plus 1 is 5, and your answer is just 5. Now, we need to go ahead and move on. If you have questions, remember, I've got office hours tonight from 2:45 to 3:15. Just email me if you need some more help. But let's go ahead and move on. So today's lesson, it's kind of confusing. Oh, shoot. I just hit the wrong button. Good. There's your assignment. I probably have the wrong date up there. No, I've got the right one. All right. So we're talking about even and odd functions. Again, you do not have to write this down, but you better take a picture. So interval notation is how we're doing this. So we're kind of putting this stuff all together. Remember, increasing, just like the stock market, if I have something that from left to right is going up, it's increasing. If I have it from left to right going down, it's decreasing. If it's going straight across, that was a terrible line, straight across, but if it's going straight across, it's constant. Now, I'm only talking about up and down or left to right, or up and down, I'm sorry, from left to right. So if it goes from left to right, if it goes up, it's increasing. From left to right, if it goes down, it's decreasing. If it goes straight across, it's constant. Now let's go ahead and look and see what this looks like. Now it says describe the graph. So let's start, and we're just describing it for right now. I want to know, where is it increasing from between what? Where is it decreasing? And where is it constant? So again, you don't have to draw this problem out in your notes, but I really hope you're following, paying attention, and trying to answer this on your own. So here's the first thing. You are only using the domain here, so you're always describing your x values. So it's increasing. I'm going to use the highlighter here real quick. I don't like this one very much, but it's increasing. So, by the way, we've got 3 different intervals. So from here to here, what's happening? Increasing, decreasing, what?
Decreasing.
Decreasing. So from left to right, it has a negative slope. What's happening between here and here?
Constant.
It's staying constant. And what's happening from here to here?
Increasing.
It's increasing, right? So this is broken up into 3 different parts. Again, it's not overly difficult. But the concept here, when you get it, it's kind of aha, it's easy. But for some people, it takes a couple days to get this. So it is increasing from this value right here on. So on what interval is it increasing? Well, what's the smallest it gets where it increases? In other words, where does it start increasing? From here, which is what?
4.
4. And how long is it increasing? What's at the end?
Positive infinity.
To positive infinity. That's exactly right. That's how you're describing the graph. So take a second and see if you can do the decreasing on your own. So take about 30 seconds, try and write the decreasing on your own. We'll talk about it, then try and do the constant. All right, so it's decreasing. Remember, you always describe it from left to right. So what do I have on the left?
Positive.
Well, it's an arrow, but remember, we're describing the x values only. So my x values go from arrow to right here, right? So how would I say an arrow on the left side, it's decreasing from where?
Negative infinity.
Exactly. So it's decreasing forever. It might have started way up here. We don't really know where exactly it started, but it decreases until it hits what? What x value?
-3.
Perfect. So that's the interval on which your y values are decreasing. So all the way from the left until you get to -3. And again, you never use brackets. It should be a parenthesis every single time on this. And then it's a constant, so it stays the same between what 2 values?
-3 and 4.
That's it. And that's how you do this. Any questions?
Can there be like more than one constant?
Absolutely there can. In fact, I'm glad you said that, so let's get to this. So let's look at this one. Now I'm going to add something else to this. I want you to find increasing intervals, decreasing intervals, and constant intervals. So we're going to kind of do this all together. So the very first thing I'm going to do is I'm going to highlight it. So let's look for increasing ones first. Well, I see that it's increasing here. Does everybody agree with that? Is there anywhere else where it's increasing?
We're between 0 and 3.
Exactly. So those are my increasing intervals. Again, what makes it increasing? The fact that it's between, or that it's going up from left to right, it's going up. Now the arrows are what makes that confusing. But so it's increasing on this interval. So what's the left side of that first interval going to be? Negative infinity. Why is it negative infinity? Because it keeps going left. And it keeps increasing until which x value?
-3.
Exactly. Now, we don't really want a union with this. You can write a union, but it's just comma. So that's one interval. What's the other interval that it's increasing on? Take a few seconds, try and write it down, and let's see. So the other interval that it is increasing is from what to what?
0 and 3.
Exactly. So I start with my x value at 0, and it stops increasing at 3, and that's it. Any questions? So let's do decreasing. It is only decreasing from here to here. So what interval is it decreasing? Again, just your x's from where to where?
-3, 0.
That's exactly right. Now, I'm not mad at this. I'm only hearing from about 5 different people here. So hopefully you guys are understanding it. Ask questions if you're not. And the last one, again, I hand wrote this and it's hard to draw these perfectly straight. But what's happening from here on?
It's staying constant.
Exactly. So if it stays constant, then it stays constant from here to arrow. So how would I say that? From what to what?
3 to positive infinity.
Exactly. So again, once you understand this concept, it's not difficult, but I absolutely understand the confusion, especially with the arrows. So you're just using your x's or your domain to identify that. Now, I'm going to go through and I'm going to erase all of that we've just done. Again, if you have other questions, you can go back, watch the video. You can stay after school for help sessions tonight. Sorry, I don't want to hand erase it because that'll take my drawing off. All right. So now let's do these last couple questions. What are my domain and my range? My domain, again, my domain is my list of x's. So with my domain, I know I start here and I've got values all the way up and it ends here. So how do I say that?
Negative infinity to positive infinity.
Good. And my range, now my range is tricky. Remember, your range is always, always, always low to high. So low, I start, and again, I start right here. That means it's going to go down forever. So how do I say it starts down forever?
Is it like negative infinity or no?
Yes, that's exactly right. So again, with my range, it's going to be negative infinity. And then it looks to me, it goes down forever. So it's coming from way down here. And then it hits this value. I don't know why that's not writing. Then it hits this value. And then it turns. Hits this value. Then it turns. Hits this value, and then it stays the same. What is the highest value that it ever gets to?
4.
And that's it. Now, hold on. So my domain and range, it's 4. What about my range is not right now? Why is this not perfect? Because it's pretty close. Why is it not perfect?
You need a bracket after the 4.
Exactly. So it has to hit the 4, which means there should be a bracket, not a parenthesis.
But I thought you said to not use brackets.
That's only on the intervals, and that's the part that throws people off. So your interval is from where to where. Your interval, something is moving. Okay? On your domain and range, that's when we use brackets. So there's 2 or 3 parts about this that are really confusing. When you're talking about your intervals, how something is moving, so it's either increasing, decreasing, or staying the same between 2 numbers, not including those numbers. Now, how I can further explain that is through part B. So it says find the values of x where my function, and by the way, f of x just means y. So find the values of x where y equals 0. In other words, find where y is 0. Well, here's where y is 0. In other words, your y is here, here, and here. So I'm going to ask you 2 questions, and you did something similar to this in Algebra 2 last year, at least you should have. But we're taking this is the next step. So find the values of x that make y equal 0. In other words, that's find your x-intercepts. Well, where does this graph cross to make y 0? -5, -1, and we'll call this like 1.5. Now he just asked, how does this relate to brackets? Because if I give you a specific value and say, well, what's the value when x is -2? What's the value when x is 0? What's the value when x is 5? What's the value when it's 3? It has a value. And all you have to do for that is this right here. Let me erase all this stuff. Hopefully you guys have it. My graph has gotten kind of sloppy. Sorry, my apologies. Don't mean to take up so much time erasing this. All right. So please, please, please watch. What this is saying is find your y value when x is 0. Well, x is 0 right here. So I only have exactly one y value when x is 0. What's that y value? It's just -3. Any questions?
So like, what would it be if it was like 1?
So if we said f of 1,
Yeah.
so f of 1, good question. So that's saying, what's my y value when x is 1? So make sure we understand what this says first of all. That throws a lot of people off. So when x is 1, I would come right here and I see that I only have one value. So I'd call it like -0.75. Now again, I hand wrote this, so it's not real good. And I know that. But hopefully you guys can see it. On any of yours tonight, it will cross at a nice, neat number. What if I said this? What's f of -3 then?
Is it 0?
So when your x is -3, so let's see, my x is -3 is right here. So when x is -3, what's my y value?
Four.
That's it. Now, just for good measure, what if I said this? Because I can say this. I want to know what are my values. So find f of x, what are my values when I get so what this is saying is, what are my x values when y is -2? So what I do is draw a line at -2, and then I circle all of those places. So what are my values? You can call it like -6, -1/2, +1/2, and that's it. So again, it's not a difficult concept, but there's a lot of people, and believe me, I understand, there's a lot of people that get confused on it, and the confusion really sets in on what is this saying.
Yeah. So for letter C,
Yep.
is it looking for the x's or the y's?
So exactly. So that's saying your x is 0. So when x is 0, what's your y value? That's all this is saying. So when x is 0, my y is -3. If it's like this, equals 4, this is saying, what are my x values when y is 4? Well, I'd come up to y is 4, and again, I'd put a line straight across, and there's only one value there. Does that make sense? This takes a little practice, and it takes a little time. So we'll go over some of that tomorrow.
How many homework problems do we have today?
Not very many, like 7. All right. So this should be pretty quick. We've only got 10 minutes. Take a picture. There's only a couple things here. Now, I put this almost by definition of textbooks. All you really need to know is there's things called even functions and odd functions. Now, I'll explain it, but this stuff down here are the only two things you really need to know. We're going to start to get into in behavior and symmetry and some of this stuff. This is the easiest thing that we will do all year. Now, the add-on to this gets a little more difficult, but when I ask you, is a function even or odd? And I'm going to give you about 30 seconds to either take a picture of it or to write down this right here. I need you to write down these two things. And by write it down, take a picture, know it. Those are what you have to have. All right, so let's discuss. An even function must only have even exponents. All of them must be even. An odd function must only have odd exponents. If you ever have a constant, the exponent is 0, which is even. In other words, if I have something like this, I do not care about anything other than the exponent, 2x to the 4th, so on and so forth. I'm only looking at the exponents. If they are all even, it's an even function, which I'll explain what that looks like and what that means later. If it's an odd function, it would be something like this: 3x cubed minus 2x. If I don't see an exponent, it's a 1. If I ever have a constant, something like this: 3x plus 5, doesn't have an x. Well, that's odd, and that's even. So my answer is it an even or odd function? It's neither. Now, hopefully you guys kind of understood that. I know I'm going fast because we've only got about 7 minutes left. It's this simple. I do not care about anything up here other than the exponents. My exponent here is a 3. What's my exponent for this one?
1.
1.
1.
Are those both even, both odd, or one of each?
Both odd.
So this is an odd function. Like I said, this is a very, very, very simple thing. Let's look at B. I'm only looking at the exponents. That's even. That's odd. So even, odd, even. Are they all the same? Are they either all even or all odd?
No.
So this is neither even nor odd. Questions?
If you had like a 5-part function and had like 4 evens and 1 odd, it would make in
Still neither. They all have to be the same. But here is something. You'll have something like this. Is that even, odd, or neither?
Even.
Even.
Even, because even, and that has x to the 0, which is even. That would be even. Now, here's the one that throws people off. Is that even, odd, or neither?
Neither.
Why is it neither?
Because
0.
0 is even.
Because that has an exponent of 0, which is even. So this would be neither, and this one would be even. Okay? Let's move on.
Wait, why is why is B neither?
Why is this one neither, or this first B?
Yeah, that one.
Because if it's even, all exponents must be even. If it's odd, all exponents have to be odd. So that's an even number, and that's an odd number, so I could have stopped right there. Once I have one even and one odd, it's neither. I'm only looking at the exponents.
Okay.
All right? Now, we're about to wrap up. I'm not going to ask you anything about this today. Really, this is just going with symmetry. Now, we're not going to get too far into this, but symmetry of a graph, if it's an even function, that means it has to have y-axis symmetry. Y-axis, here's the y-axis, which means I could fold this part over onto this part. It's perfectly symmetric this way. If it's an odd function, it must have symmetry about the origin, which means it's a rotation. So think about it this way. If I rotate it, kind of like a fan, this part would become exactly what this part is as long as it's rotating. And that's called odd symmetry or origin symmetry. Now, we're not going to get too far into that, but just know, for instance, any SAT or ACT, that's what your symmetry is telling you. You should have studied that a little bit, just a little bit in geometry. Any questions? Your homework tonight is up on Big Ideas. So I would mark it as page 37 and 38. And this is going to be your 1.3 assignment. And call it even odd. By the way, we have a new student in this class. So how we do homework is we have homework checks every Friday straight from your homework. So make sure that you write it out, write the question out. If there's a graph, you don't need to do it, but I need to see all of your work. So you have 1, 2, 3, 63, 65, and 67. So that's 3 more problems, odd only. Now the directions are going to say do it graphing, but you only have to do it algebraically. Now, if it just says even or odd, just tell me whether it's even or odd and explain why. A quick explanation why. For instance, you could say it has an even exponent and an odd exponent. Or it has 3 evens, 1 odd. Or it has all even exponents. Or it has all odd exponents. Then 79 through 82, you're doing all of those problems. So 79, 80, 81, 82, but you're only doing part A. So it's got part like A, B, and C to it. You're only doing part A. So you've got 10 questions. Most of this should not be too difficult. We will go over it tomorrow.
What book do we use? You said Big Ideas.
I said Big Ideas.
Yeah.
Hold on. Did I say it or did I put it in here?
No, you just said Big Ideas.
That's what we use in Algebra 2. I'm sorry. That was a slip. So I want to make sure that we are on the right set here. So class resources. Yeah, there you go. So your assignment is up there. So if I said Big Ideas, that's my fault. We do that in Algebra 2 and 2X. So your assignment is up there. Just 10 questions, and half of those are even and odd. And you don't even have to show the work, just explain your answer. All right. So we'll go ahead and wrap it up. If you guys have any other questions, please let me know.